Welcome to today's paper reading. Today's paper is titled, Corrective Retrieval Augmented Generation. This paper was published on the AR14 preprint by Shi-Qi and colleagues from the National Engineering Research Center of Speech and Language Information Processing at the University of Science and Technology of China. The abstract highlights the inherent issue of hallucinations in large language models, LLMs, where the accuracy of generated text cannot be fully assured by the model's internal knowledge. Although retrieval augmented generation, RAG, is a viable solution, it faces challenges due to its dependence on the relevance of retrieved documents. This raises concerns about the model's performance when retrieval fails. To address these issues, the authors propose Corrective Retrieval Augmented Generation, CRAG, which includes a lightweight retrieval evaluator to assess document quality and trigger appropriate actions based on confidence levels. Additionally, CRAG employs a decompose then recompose algorithm to focus on key information and filter out irrelevant data. The system is designed to be plug-and-play, compatible with various RAG-based approaches, and has shown significant improvements in performance across multiple datasets. Large language models, LLMs, have garnered significant attention due to their impressive capabilities in understanding instructions and generating fluent texts. However, these models often exhibit hallucinations, primarily due to factual errors and the inability to ensure text accuracy solely through parametric knowledge. To address these issues, Retrieval Augmented Generation, RAG, has been introduced, which augments model input with relevant documents retrieved from an external knowledge corpus. Despite its practicality, RAG's effectiveness depends heavily on the relevance and accuracy of the retrieved documents. This paper proposes a method named Corrective Retrieval Augmented Generation, CRAG, to self-correct the retriever's results and enhance document utilization for generation. CRAG includes a lightweight retrieval evaluator to assess document quality, and integrates large-scale web searches to broaden the scope of retrieved information. Figure 1 illustrates the consequences of using a low-quality retriever in Retrieval Augmented Generation RAG. It shows that such a retriever is likely to introduce a significant amount of irrelevant information, which can hinder the generator's ability to acquire accurate knowledge. This can potentially mislead the generator, leading to outputs that are not factually correct. The figure emphasizes the importance of a high-quality retriever in ensuring the accuracy and reliability of the generated content. The issue of hallucinations in large language models, LLMs, is a significant concern. These hallucinations often arise from outdated or incorrect information, exacerbated by factors such as unregulated training data and low-quality sampling data. To address these issues, Retrieval Augmented Generation (RAG) has been proposed. RAG enhances the input questions of generative LLMs with retrieved documents from sources like Wikipedia, thereby improving performance in knowledge-intensive tasks. More advanced RAG approaches have been developed, including selective retrieval mechanisms and the use of critic models to determine retrieval necessity. Additionally, methods like toolformer integrate API calls for external knowledge, and some approaches dynamically decide when to retrieve in long-text generation tasks. This study differentiates itself by focusing on scenarios where the retriever returns inaccurate results, aiming to develop corrective strategies for RAG to enhance its robustness. In this section, the task formulation is described. The system is composed of two main components, the retriever R and the generator G. The retriever's role is to fetch the top K most relevant documents D from a large corpus C based on the input X. Subsequently, the generator G uses both the input X and the retrieved documents D to produce the output Y. This process can be mathematically represented as P, Y, X equals P, D, X, P, Y, D, X. This formulation highlights the interdependence of the retriever and generator, emphasizing the need for accurate retrieval to ensure satisfactory generation. The CRAG model at inference involves several key steps. First, a retrieval evaluator is constructed to estimate the relevance of retrieved documents to the input query. This evaluator quantifies relevance into confidence scores, which trigger different actions, correct, incorrect, or ambiguous. If correct is triggered, the retrieved documents undergo knowledge refinement through decomposition and recomposition. If incorrect is triggered, web searches are conducted to find complementary knowledge. In the case of ambiguous, both refinement and web search results are combined. This approach ensures robustness by integrating both internal and external knowledge sources. Figure 2 provides an overview of the Corrective Retrieval Augmented Generation (CRAG) model during inference. The figure illustrates the process where a retrieval evaluator is constructed to assess the relevance of the retrieved documents to the input query. Based on the relevance evaluation, a confidence degree is estimated, which triggers one of three possible actions: correct, incorrect, or ambiguous. For the correct action, the retrieved documents undergo a knowledge refinement process to extract the most critical information. If the incorrect action is triggered, the model resorts to web searches to find complementary knowledge. The ambiguous action combines both refined knowledge and web search results to ensure robustness. This overview highlights the corrective strategies designed to improve the robustness and accuracy of the generation process in CRAG. The experiments were designed to demonstrate CRAG's adaptability and generalizability across various generation tasks. 4 datasets were used for evaluation: PopQA for short-form generation, biography for long-form generation, PubHealth for true or false questions, and ArcChallenge for multiple-choice questions. The evaluation metrics included accuracy for PopQA, PubHealth, and ArcChallenge, and FactScore for biography. Baselines were compared in 3 categories: without retrieval, standard RAG, and advanced RAG. Key findings show that CRAG significantly improves the performance of RAG and self-RAG across different datasets, demonstrating its generalizability and flexibility in replacing the underlying LLM generator. Table 1 presents the overall evaluation results on the test sets of 4 datasets, including PopQA, biography, PubHealth, and ArcChallenge. The results are categorized based on the generation LLMs used. Key metrics such as accuracy and FactScore are used to evaluate performance. The best performance among all methods in LLMs is indicated by bold numbers, while gray-colored bold scores highlight the best performance using a specific LLM. Results marked with an asterisk symbol were reproduced by the authors, with other results cited from their original papers. Table 2 presents an ablation study examining the impact of removing each single action on the PopQA dataset in terms of accuracy. The study shows a performance drop when any of the actions, correct, incorrect, or ambiguous, are removed, indicating the importance of each action in maintaining the robustness of the generation process. Specifically, when correct or incorrect is removed, it merges with ambiguous, and when ambiguous is removed, a single threshold is used for correct or incorrect actions. Table 3 presents an ablation study on the PopQA dataset, focusing on the impact of removing key knowledge utilization operations on accuracy. The operations examined include document refinement, search query rewriting, and selection. The models tested are Llama 2 HF7B, Self-RAG Llama 2-7B, CRAG, and Self-CRAG. The results show a consistent accuracy drop when any of these operations are removed, indicating their critical role in maintaining model performance. Table 4 evaluates the performance of our retrieval evaluator, based on T5, against ChatGPT in terms of accuracy on the PopQA dataset. The results indicate that the T5-based retrieval evaluator significantly outperforms ChatGPT across all settings, demonstrating its effectiveness in assessing the quality of document retrieval results. This comparison highlights the evaluator's capability to accurately determine the overall quality of retrieval outcomes, which is crucial for the performance of the entire system. Figure 3 illustrates the generation performance of 4 models: Self-RAG, Self-CRAG, RAG, and CRAG, under different retrieval performance conditions on the PopQA dataset using Self-RAG Llama 7B. The graph shows a clear decline in generation performance as retrieval quality decreases, highlighting the model's reliance on accurate retrieval. Notably, Self-CRAG demonstrates a more resilient performance drop compared to Self-RAG, suggesting its enhanced robustness to retrieval quality variations. The lower horizontal line indicates the performance of the generator without any retrieval, serving as a baseline for comparison. The paper introduces Corrective Retrieval Augmented Generation, CRAG, to enhance the robustness of generation by addressing issues where RAG-based approaches fail due to incorrect retrieval. CRAG employs a lightweight retrieval evaluator to estimate and trigger 3 distinct knowledge retrieval actions. By integrating web search and optimizing knowledge utilization, CRAG significantly improves automatic self-correction and the efficient use of retrieved documents. Experimental results show CRAG's adaptability to various RAG-based approaches and its generalizability across both short and long-form generation tasks. However, the paper acknowledges limitations, including the need for more accurate and effective methods to detect and correct wrong knowledge, the necessity of fine-tuning the retrieval evaluator, and potential bias introduced by web searches. Future work will focus on developing a more stable and reliable method for retrieval augmentation. Thank you for watching.